Hey guys, hope you're having a great day. Here we go on 7.5's lesson. We started talking about this yesterday with our report and practice journal. This is the converse or opposite of the Pythagorean theorem, which is the distance formula. So getting started on the key idea, jot this down. The converse of the Pythagorean theorem, which is true for right triangles. If the equation a squared plus b squared equals c squared is true for the side lengths of the triangle, then the triangle is a right triangle. And it's probably pretty obvious by now, but make sure that you're labeling C as the hypotenuse, which is the longest side across from the right angle. Okay. For example 1, tell whether each triangle is a right triangle. We obviously know that the hypotenuse should be the longest side. So looking at letter A, I know that 41 centimeters has to be the C, and it doesn't matter which one I label as A and B for the legs, 9 and 40, because I'm going to end up adding them together. So what I'm going to do is make sure that the two legs squared added together equals the hypotenuse squared. So I'd say 9 squared plus 40 squared equals 41 squared. I'm not going to work out my multiplication this time, but if you're not sure what these are, obviously make sure that you're multiplying them off to the side in your notes. So we all know that 9 squared is 81, 40 squared is just going to be 4 squared, 16, and then 2 zeros since we're squaring it, and 41 squared is 1,681. So when you add together your a squared and b squared, 81 and 1600 is going to be 1681, which is what c squared equaled. So yes, this is a right triangle. Okay, for letter B, even though they rotated the triangle around, we can see that the quote-unquote hypotenuse is here. The reason I said quote-unquote is because it doesn't look like a right triangle, but remember that we have to prove it. So we think we know what our answer is going to be, but we're going to mathematically prove it. So it doesn't matter which one you label as A and B. Just make sure that C is 24. Okay, so once again, we're going to start evaluating this. 18 squared is 324, and 24 squared is 576. When you add your two legs squared, it's 468, which does not equal 576. So just as we anticipated, no, this is not. You're right. Triangle. Okay. So here are the first two on your own. Pause the video, work these two out, and then come back and check your answers. Okay, I pulled a trick on you this time. I worked them out beforehand to save some time. Okay, so looking at number 1, it should have been no. We're looking at this. We have 20 squared and 21 squared as our legs, and 28 is the hypotenuse. So we're squaring that. We're going to evaluate them. 20 squared is 400, 21 squared is 441, and 28 squared is 784. So when we add those two legs up, we do not get the hypotenuse square. So number 1 was no. And number 2, I don't know if you saw my little trick here, but I did not want to deal with 75/100ths squared and 1 and 25/100 squared, so I thought those were easy fractions. I made the 1 and 25/100ths an improper fraction because it's just easier to square a numerator and denominator. So I don't know if any of you did it this way, but for the future, you can do this, it's a little bit easier. So just to kind of explain, this 16 over 16 is the 1 squared if it were 1 over 1 and I was just making it a common denominator. I'd get 16 over 16. I need that common denominator so that I can add the 9 and the 16. But I do end up getting the same thing on both sides, so yes, this is a right triangle. Okay, so this is from your book. This is our second key idea. When it says on page 319, that's talking about in the RPJ. So we developed this yesterday with our little theorem yesterday from our RPJ. And basically we were looking at the distance between 2 points. So if we're looking at the distance between any 2 points, x1 and y1, here is x1, y1, and x2, y2 is given by the formula. And here's where we developed it. If we've got this point here and this point here, we know that that's obviously going to be the hypotenuse side. So we would have to take the quote-unquote road map instead of the helicopter distance to get from one point to the other. So we know the vertical distance is going to be the difference between the y's, so y2 minus y1. The horizontal distance is going to be the difference between the x's, so x2 minus x1, sub 1 and sub 2. And remember, it doesn't matter what order you subtract, just make sure that whichever point you started with, you start with in the second one. So here is the formula. We're going to take the square root of the x's subtracted squared plus the y's subtracted and squared. Let's do an example. Okay, so we have find the distance between 1, 5 and negative 4, negative 2. So just before we start, could you pull out a piece of graph paper, plot these 2 points, count the driving distance to find your legs, and solve for the hypotenuse using the Pythagorean theorem? Sure, but the whole point of not having to do that is the distance formula. So that's why we have this, for convenience. So just figure out which one you want to be x1 and y1. I always just go in order. The only other thing you could do is think about manipulating if you don't want to deal with subtracting a negative amount, because you might make a mistake there. But we know that the distance formula says we're going to subtract x2, x sub 2, minus x sub 1, and we're going to square it, plus y sub 2 minus y sub 1 squared. So then we're simply just simplifying this. I do it one step at a time to make sure I don't make any mistakes. Negative 4 minus 1 is negative 5. Negative 2 minus 5 is negative 7. And please don't forget your parentheses, because everything should end up positive because you're squaring it. So negative 5 and negative 5 is going to give me 25. And negative 7 is going to give me 49. I guess I didn't really need those parentheses at this point, but that's okay. Okay, so when I add 25 and 49, I'm going to get 74. And I can actually evaluate the square root of 74, or I can leave it. At this point, you can just leave it. But if this is like a real life problem, you were actually trying to find a numerical answer, you could approximate. You learned how to do that last week, approximating. So just like first thought here is 81. I know it's going to be a little bit less than 9, in between 8 and 9. Okay, so for our real life application, you design a football play in which a player runs down the field, makes a 90-degree turn, and runs to the corner of the end zone. Your friend runs the play as shown. So the question is, did your friend actually make a 90-degree turn? You told him to, but did he actually do it? So noticing this graph has units going up by tens. That's somewhat important for you to note. We are questioning what is the length of each distance so that we can figure out if it is a right triangle. So this is pretty involved. we have to find D1, D2, and D3. So in order to do that, we're going to have to use the distance formula 3 times. So let's start with the first one. For the first distance, D sub 1, we need to use the points 30, 20, and 60, 50. So it doesn't matter which one you label which. But here we go. The distance of the first leg would have to be 30 minus 60, or 60 minus 30, whichever way you ordered these. And I started with this one, so I'm starting with 20 minus 50. And then I'm just going to simplify. And that's going to give me negative 30 squared plus negative 30 squared. And negative 30 squared is going to be 900. And another 900. So that's going to give me 1,800 feet. But it's actually the square root of 1,800 feet. So D sub 1 is 1,800 feet. Okay, I'm probably going to run out of room here. I might need to erase this, so make sure you got this down. I'll start D sub 2 in another color. Here's D sub 2, which is this one right here. And because I already have this one labeled, I'm going to make this x1, y1. So the distance 2 is going to be y2, so 20. Oh, I'm sorry, x, not y. I'm thinking of slope. Don't make that mistake. Alright, let me try that again. So x2, 30 minus 80 squared plus 20 minus negative 30 squared. Alright, so 30 minus 80 is going to give me negative 50 squared plus 20 minus negative 30. It's going to turn into plus positive, so that's positive 50 squared. And I'm running out of room, so I'm going to continue up here. So that's going to be 2,500 plus another 2,500. And that will give me the square root of 5,000 feet. Okay, let's see if I can fit this on the same page. Distance 3. Oh boy, it's going to be tight. I'll try. Okay, so distance 3. I've already got this one labeled, so I will... Well, actually, they're both labeled, so I'm just going to change this one to x2, y2. Alright, x2 is 80, x1 is 60. So 80 minus 60 squared plus y2 is negative 30 and y1 is 50. So minus 50 squared. Sorry, looks terrible. Move over. 80 minus 60 is going to give me negative 20 squared plus, what does that even say? Negative 30 minus 50, so that's a negative 80 squared. Okay, and then again, negative 20 squared is going to be 400. Negative 80 squared is going to be 1,600. Nope, sorry, 6,400. not 8 times 2, but 8 times 8. And then add those together and you're going to get the square root of 6,800 feet. Okay, we are almost done. So now that we know the lengths of these, we are going to prove if it's a right triangle by finding the biggest one, and that's going to be C. So with another color, here we go. This is C. And then it doesn't matter which one we label as A and B, but our goal is to prove that when we set these equal to C squared, A squared plus B squared will equal C squared. So I'm just making some space up here. And we will prove if this is a right triangle. Okay. So we're going to say the square root of 1800 squared plus the square root of 5000 squared should equal the square root of 6,800 squared. Okay. So we all know that squaring a square root cancels it out. This is actually pretty easy from this point forward. I'm just erasing so that it's not confusing. We see exactly what's about to happen. Alright, good enough. That's going to cancel out. So we have 1800 plus 5000 equals 6,800. When we add these together, we get 6,800 does equal 6,800. So yes, the friend did make a 90-degree turn. Okay. So that was a lot of work, but we got it. I am not going to make you do the on your own, asking you to do that crazy process again. If you have a question about that, let's rewatch that section of the video. I'm also going to skip on your own number 3. I'll show you how to work it out, but it's just way too easy. So pause the video and do numbers 4 and 5 on your own, and then come back and check your answers. Alright, so once again, I worked this out ahead of time to save time, since that last example was very long. Okay, so the reason we skipped number 3 was because, I don't know if you noticed this, but the first coordinate point was 0, 0, so you should have known that your distances were going to be 4 and 5. So 4 squared and 5 squared, that's going to give you 1625, so square root of 41. Here's number 4 and number 5. Number 5 I did evaluate all the way down because it was a perfect square. Number 4 you didn't have to, unless it asks you, like specifically, you don't have to evaluate exactly what 85 is, but we know it's going to be a little bit more than 9, since 9 squared is 81. Okay, so at this point we're going to do our mini assessment. Sorry that this is so blurry. I'm going to write these over on the side just in case there's any confusion. Just double check that these are the right things that I'm giving you. Okay, so this is 32 meters, 56 meters, and 64 meters. Number 2 is 1 8/10 miles, 8 miles, and 8 2/10 miles. And so for these two, you're telling whether the triangle is a right triangle, so you're simply saying yes or no. And then finally for number 3, find the distance between the 2 points. This says -3, -1, and the other point is 6, 2. Okay, so write these down in your notebooks and then submit your answers on the Google survey. Also, don't forget to take a picture of all of your notes, including this mini assessment. You don't have to worry about grading the on your owns, just make corrections because you are doing them on your own. All right, guys, talk to you later.